Okay, let's consider a situation where a decision to introduce a new product to the market is required. From the market, the odds can be assigned to events high sales, regular sales, and low sales. For high sales, we have a probability of 0.6. For regular sales, we have a probability of 0.15. And for low sales, we have a probability of 0.25. There is a benefit of 1,250,000 pesos if you have high sales, a benefit of 680,000 pesos if sales are regular, and a financial loss of 2,350,000 pesos if you have low sales. Before you make a decision, you can conduct a survey that allows you to have more information about the chances of having high sales, low sales, or regular sales. This survey will cost 150,000 pesos. Now, suppose that the results that the survey can give are three. The survey can predict the success of the new product, it can predict the failure of the new product, or it can give unfinished or non-conclusive results. Now, if we know from the results of other surveys conducted in the past that when a product has high potential sales, the survey predicts success 90% of the time, it predicts failure 5% of the time, and it doesn't give conclusive results on another 5% of the time. When the potential sales were regular, the survey predicts success 60% of the time, it predicts failure 30% of the time, and it doesn't give any conclusive results on 10% of the time. And to finish, when the potential sales are low, the survey predicts success 10% of the time, it predicts failure 80% of the time, and it doesn't give any conclusive results 10% of the time. And we are asked to take a decision to define the situation that we have described. Let's plan. We are going to construct a decision tree. We are going to solve it, and we need to answer if we will apply the survey and why, if we are going to introduce the product and why, and what is the real expected benefit of this operation. Okay, so first of all, we have some data that we need to analyze and to extract from the problem. We have some probabilities, the probabilities of high sales, regular sales, and low sales. We have benefits applying or not applying the survey, and we need to remember that the cost of the survey is 150,000 pesos. So when we apply the survey, when the benefit with survey, it's going to be the benefit with no survey minus the cost of the study. And we have a second set of data that are probabilities. And according to the Bayer theorem, we have probabilities of success due high sales, of success due regular sales, and success due low sales. We have also probabilities of failure doing high sales, of non-conclusive results due high sales, of failure due regular sales, of non-conclusive results due regular sales, of success due low sales, of failure due low sales, and of non-conclusive results due low sales. And if you add the quantities in each column, you are going to add up to 1. And those are the probabilities that the studies gave us in the past. With the same information, we can construct this decision tree. We have a set of branches when we have a survey. That's the S part up here. and a set of branches when we don't have a survey. When we apply the survey can give us three different probabilistic results. It can predict success, failure, or non-conclusive results. In either of these cases, we can decide to introduce or do not introduce the product. When the product is introduced, we can expect high sales, regular sales, or low sales in each of the cases, in each of the three main branches when we apply the survey. These probabilities, according to Bayes' theorem, are, for example, this is the probability of high sales due success in the survey. This is the probability of regular sales due success and of low sales due success. In the branch of failure, we have the probability of high sales due failure, regular sales due failure, and low sales due failure. And in the branch of non-conclusive results, we also have the probability of high sales due non-conclusive results, of regular sales due non-conclusive results, and of low sales due non-conclusive results. This is the part of conducting the survey. When we decide not to apply the survey, we just have to decide if we introduce or do not introduce the product. And if we introduce it, we are having the probability of high sales, regular sales, and low sales. And this probability, these probabilities don't depend on anything. So they are just the probabilities of high sales, regular sales, and low sales. In difference with the probabilities in this part of the tree, where they depend on the results of the survey, success, failure, and non-conclusive results, and that's why we applied the Bayes theorem. Now, what information do I need? My information gives me these probabilities. The probabilities of sales due, of success due high sales, failure high sales, etc. But we need not sales due success due high sales. We need high sales due success. We need regular sales due success. And we have success due regular sales. We need low sales due success, and we have success due low sales. And the same happens with failure and non-conclusive results. So we have this question: are they the same probabilities? Let's ask Bayes. And the theorem says that the probability of an event A happening after an event B already has happened is the probability of the intersection of both events divided by the probability of the event that already took place. Now, for example, what we are trying to find out is the probability of sales of success due high sales is the same as the probability of high sales due success. According to Bayes, the probability of success due high sales is the probability of the intersection of success and high sales divided by the probability of high sales. And the probability of high sales due success is the probability of high sales intersection with success divided by the probability of success. If we analyze the first part of each equation, we can find that they are kind of the same. They are the probabilities of intersections. In the first equation is the probability of the intersection between success and high sales, and in the second equation it's the probability of the intersection of high sales with the probability of success. They are the same. And they are the same because if I have a group called A and a group called B, and we intersect them, the intersection is the same if it's A intersection with B or B intersection with A. So the first part is the same. But what about the second part? Is the probability of high sales exactly the same as the probability of success? They are not the same. So we need another type of kind of process to analyze this information. Now we are going to apply the Bayes theorem for the probabilities that we need. And with this information, we can clear the equation and try to find the probability of the intersection. And having the probability of the intersection from the information that we already have, we can clear all the equations to find all the probabilities of all the intersections that we need. Since the probability of the intersections are the same in both analyses that we just did, we can apply the same equation, the same clearance of equation to calculate the probabilities of all the intersections. And doing the calculation, we just multiply in the first equation the probability of success due higher sales times the probability of high sales, and we find the probability of the intersection of higher sales and success. This information, this 0.9 and this 0.6, are in the data that the problem gave us as the initial information to solve this problem. And we do the same for the other intersections, and we have all these calculations that represents every intersection that we need. But we are just half the way to find the probability that we need. We need to put the data in a chart just like this. So in the rows we are having the high sales, regular sales, and low sales. In the columns we are putting success, failure, and non-conclusive results. And in each sales we are putting the probability of every intersection. And that's the information that we just have calculated. If we analyze a little bit of this chart, we can see that if we add all the rows, we have the initial probabilities that we already knew. That if we add 0.54 plus 0.03 plus 0.03, we have 0.6, that it's the probability of high sales. If we add the second row, all the elements in the second row, we have 0.15, that it's the probability of regular sales. And for the third row, we can add up to the probability of low sales. So if adding each row gave us this information that we already had, what will happen if we add all the columns, all the data in each column, the column of success, failure, and non-conclusive results? We will be having the probability of success, failure, and non-conclusive results that we need to apply again the Bayes theorem to solve the probabilities in our decision tree. We add them, and we have these results as the probabilities of success, failure, and non-conclusive results. Now, we apply the Bayes theorem, and we find the conditional probabilities for each branch of the tree. The probability of high sales due success, regular sales due success, low sales due success, and the same for failure and non-conclusive results. When we apply the theorem, we get this calculation, and we have these probabilities for each of the branches of our decision tree. With this calculation and the previous ones, we can solve the decision tree. This is the decision tree that we need to solve. This part, we already saw it at the beginning of this video, and we need to calculate the benefit for each branch. So this branch, as being the probability of high sales due success, we are going to multiply it by the benefit of high sales with the survey, and that quantity is 1,100,000 pesos times the probability that we just calculated. We are going to add it with the multiplication of the probability of regular sales due success times the benefit of regular sales with the survey, and we are also going to add it with the multiplication of the probability of low sales due success times the benefit of low sales with the survey. And these quantities are the quantities right here. For high sales, for regular sales, and for low sales with the survey. The same applies to the branch of failure and the branch of non-conclusive results. Then, when we have a result for each of the branches, we need to multiply it times the probability of each of the three main branches: the probability of success, the probability of failure, and the probability of non-conclusive results. And if we add these three, we are going to have the benefit with the survey. The benefit, the expected benefit with applying the survey. And this will be the solution for this part of the tree. For the lower part of the decision tree, we just need to multiply the probability of high sales times the benefit of high sales with no survey. That will be 1,250,000 for high sales times 0.6. The probability of regular sales, that is 0.15, times the benefit of regular sales with no survey, that it will be 680,000 pesos, and the probability of low sales times the benefit of low sales. This will be this 0.25 times 2,350,000 pesos. Okay, doing these calculations, we have this result. These are the probabilities, these are the conditional probabilities that we already calculated. These are the expected benefits applying the survey. In this case, it's for high sales, regular sales, low sales, and the same applies with the branches of failure and non-conclusive results. Then, solving this part of each branch, then we are going to multiply it by the probability of success, in this case, of failure, in this part of the tree, and of non-conclusive results in the final part of these branches for the decision tree. Then we add this part, these results, we add them, and we have an expected benefit of 114,500 pesos. This is the expected benefit with applying the survey. When we do the same for the lower part of our tree, the part where we do not apply the survey, we get a benefit of 264,500 pesos. We compare the two benefits, and we can decide to apply or not to apply the survey according to the greater benefit. But we need to think a little bit about the benefits of applying or not applying the survey. This is a simple way of deciding just by choosing the greater benefit. In this case, we will be going with this part of the tree of not applying the survey. But how do I decide, or how do we decide if we will introduce or we won't introduce the product, the new product? First of all, we need to place the real benefits of applying or not applying the survey in a straight line. So if we decide to apply the survey, these are the benefits: high sales, regular sales, and low sales. These are the real quantities that we expect to get from the market when we introduce the product. If we decide not to apply the survey, we have different benefits because we don't have to consider the cost of the survey. Then we place the expected profit according to the calculations we just made. So if we decide to apply the survey, we have this benefit, and if we do not decide to apply the survey, we have this benefit right here. And we analyze to which of the values this benefit is closer to. So what we see in a first analysis is that we are not going to have high sales in each of the cases, because the expected benefit it's between the benefits of regular sales and low sales. Now we have to analyze to which of the limits of the interval this quantity is closer to. In both cases, is closer to the value of regular sales. So according to this, the result of our operation is that even if we apply or we do not apply the survey, we are going to have regular sales. If we apply the survey, we are going to have a benefit of 530,000 pesos. And if we do not apply the survey, we are going to have a benefit of 680,000 pesos. Finally, this is the decisions that we need to make. And that's the solution when we apply decision trees and the buyer theorem for this type of probabilities.